So here we've got laws of indices, also sometimes known as power laws. So when you're multiplying two things, you add their powers. So for example, 5 cubed times 5 to the 7 would be 5 to the 10. When you're dividing, you subtract the powers. So 5 cubed divided by 5 to the 7 would be 5 to the minus 4. And when you've got a power to a power, you times the two. So 5 cubed to the power of 7 would be 5 to the 21. Now that's all basic power laws that we expect you to know before you start. Now we're going to extend this to say what happens if the power is negative or a fraction. So the rule is, if the power is negative, the minus part of the power means 1 over. So whatever the negative power was, it becomes positive on the bottom of the fraction. For example, 5 to the minus 2 means 1 over 5 to the plus 2, which means 1 over 25. 3 to the minus 3 means 1 over 3 to the plus 3, which is 1 over 27. See if you can work out the last example, 2 to the minus 4. It should have been 1/16. Now this links with what you've probably seen in your science already. For example, speeds are often given in meters per second to the minus 1. It's the same thing. S to the minus 1 means 1 over S to the 1. So this is meters times 1 over seconds. In other words, meters per second. So that's why meters per second is sometimes written in that format. So this is how we deal with it if it's a negative power. If it's a fractional power, we're going to start off by concentrating only on fractions with a 1 on the top. Then what that means is it's the 8th root of x. So if I had x to the 1/2, it would be the 2nd root of x, so the square root. If I had x to the 1/3, it would be the cube root of x. X to the 1/4 would be the 4th root of x, and so on. So 100 to the power of half means the square root of 100, which is 10. 27 to the 1/3 means the cube root of 27, which is 3. 3 cubed is 27, so the cube root of 27 is 3. Now the last example combines both of the two bits that we've done so far, negative powers and fractional powers. So freeze the screen, take a moment and see if you can have a go at it. What you should have got was a half. We're going to deal with the minus first, so 16 to the minus 1/4 is 1 over 16 to the 1/4, which means 1 over the 4th root of 16. And the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. In other words, 2 to the 4 is 16, so the 4th root of 16 is 2. Now the final part is what happens if you have a fraction where the top of the fraction is not 1. And for this, we're going to go back to this rule here. Okay, so all we're doing is using a rule that you already know. We're going to break the fraction down. So x to the b over a is x to the 1 over a to the power of b. That probably looks easier if you turn it backwards. Then it's in the same format as the rule above. A power to a power would be what you'd get if you multiplied them together. Once I've done this, I know how to deal with the bit inside the bracket because it's the same as these examples. So I work out what's inside the bracket and then I just raise that answer to whatever power b is at the end. So for example, 27 to the 2/3 is 27 to the 1/3 squared. Focusing inside the bracket, 27 to the 1/3 is the cube root of 27, which is 3. I've already done that here. So it's 3 squared, and 3 squared is 9. 32 to the 3/5 is 32 to the 1/5 cubed. 32 to the 1/5 is the 5th root of 32. So you've got to find something which, when you times it by itself 5 times, will give you 32. And that turns out to be 2. So it's 2 cubed, and 2 times 2 times 2 is 8. Now in the last example we put everything together, so freeze the screen, have a try at it. And you should have got 1 over 125. Okay, so I've dealt with the minus first, just as the same as I did in this example here, so that's 1 over 25 to the 3 over 2. I then dealt with the fraction by turning it into a fraction with 1 on the top, so 25 to the 3 over 2 is 25 to the 1/2 cubed. The power of half means the square root. Square root of 25 is 5. 5 cubed is 125.